turn it over to Chris first and then to you, Clint.
We're good.
All right, you recording? Cool. All right. So anyway, hopefully everybody was able to transfer over to the Zoom meetup. And Scott brought up a good point that we might have to have some contingency meetups in place. So, and also my dog decided to bark. So yeah, I just want to kind of cover some of the meetups that are coming up through the end of the year, and then I'll turn it over to our sponsor, Beacon Hill. So for tonight, getting a late start, Cameron will be talking about functional programming through construction. I've seen Cameron speak at a couple other meetups, and yes, you're in for a treat. Your link talk, by the way, rebuilding link, Cameron, that's a really good talk for anybody to catch that. But yeah, this will be worth your time. And then before that, we're going to have a lightning talk from Clint when it comes to what every developer needs to know about Lean and Agile. So looking forward to that too. In the coming months, next month, we have Sarah Ford. She's going to give a talk on basically some aspects of Git. And there'll be a lightning talk before that one as well from Michael Fritz. Well, I call him Fritz. I can't even pronounce his last name. But anyway, he's going to give a talk basically on dealing with sales in some aspects that everybody should be aware of. And then in November, we'll have Clint back doing the main talk. I'm assuming still on Blazor, Clint? So far, yes?
We'll see, yeah.
We'll see. If you're still interested in it. All right, so we'll be posting those details soon. And we'll have a holiday party. So we'll probably might be an online panel as my guess, but we will be holding something when it comes to what we would normally do in December. So most likely another panel. All right, so Chris, I'm going to go ahead and turn it over to you to say a few words. You don't have to share your screen or anything, but you can just go ahead and unmute and show yourself and go from there. Is Chris in the meeting? That's the question. Oh, I see him.
I'm assuming not me, Chris, but another Chris from Beacon
Right.
Hill. I just wanted to be sure. But I'm happy to talk if you want. I can do that.
By the way, Chris Cadell, we did try to let you in, I swear, into the Teams meetup, but
I kept pounding on the doors and nobody would let me in.
Everybody else was able to get in.
So sad.
For whatever reason, the teams did not like you. So, all right, Chris, I see you there, but you might need to unmute yourself.
I can't unmute him. I wonder if his microphone's not working.
I wonder if he's still connected to Teams, and he might have to disconnect to that. I'll tell you what. Hey, Clint, if you want to go, since we're recording, if you want to start your talk, and then we'll have Chris say a few things in between talks.
Yeah, sure. Why not?
All right.
All right, let me share screen.
Thanks.
Welcome, everyone. I wanted to share with you some things that we've been doing here recently in one of our big projects. It's kind of made me think about what works and what doesn't work with Agile. And, you know, this isn't an all-encompassing training course on Agile, but it just kind of the things that come top of mind when I bring team members on. We've had a team that started off with 3 and it grew to about 20 people. And of course, every time someone joined, I had to kind of explain what we're doing and how we're doing it. And inevitably it comes up, well, why are you doing this? So I've put together a little bit of a kind of a thought process on kind of how I see Lean and Agile. So Lean at its fundamental root is a manufacturing production approach. That's all it is. It's got some principles, got a body of practices that people have learned to use, and it's proven itself in both mechanical and manufacturing as well as other industries. You see it used in healthcare and underwriting, all kinds of places. But it works really well in software development. And some of the kind of the core principles or tenets behind Lean are defining what your value is. Oh, I'm hearing some feedback. Can we make sure we're muted? There we go. Defining what your value is. And there's a couple practices that we use on a regular basis. One of them is what's called story mapping, where we get our stakeholders and our engineers in a big giant room and kind of tell each other what we're trying to do, how we're going to do it. And then we break out and look at the different users that are involved and kind of the core scenarios and tasks they do, and we break those down into stories. And in ideal world, they have some level of a narrative to them that kind of talks about, what's their, the term is a customer journey, but what is the journey a user's going through when they want to use your software and get their job done or get their need met. Obviously, those stories look something like this to some degree, or of greater or lesser elaboration. When we have teams that are really small and that move really fast, they tend to be fairly light, especially if the developers on the team understand the domain and are really in tight collaboration with the customers. You don't need a lot of this. You can take some shortcuts, which is really one of the things that Lean's about, is eliminating waste. And I can tell you, I've had teams and I've had groups that sat down and said, we have to have stories defined exactly like this or we won't code them. And, taking a hard stance on something like that isn't necessarily in the spirit of Lean. The spirit of Lean is like the least cost and least amount of transition to get something defined, to give it to value. So it really comes down to the team, their level of collaboration, and what level of need they need to be able to be told what they need to build it, and then verify it. And so, like I said, I don't have a lot of hard, fast rules on this, and I'll actually show you guys, well, I can show you now what we're doing on a project. It's called Aspire. It's a kind of a ERP package for lawn care companies and landscapers. And you can see the application here, but if you take a look at our board, our backlog, we've got some epics in here and we've got some stories, but if you'll notice, a lot of these stories are pretty minimal. But that's because both the developers and the customers and stakeholders know exactly what we're talking about. And what we do is we collaboratively fill in the description with details as we discuss them and learn about what we need to build. So again, in a spirit of Lean, we're not doing anything more than we absolutely have to do to figure out what to build it, and verify it. Some teams like more formality. Other teams like this team, like we go and we're cranking because we have a really great relationship between the two sides. We define a value stream, which is how are we going to build that product or build that value that we defined in the previous step. And this is an example of one that I worked with another client about a year ago. They needed definitions so that they could put it in kind of their body of knowledge of what it meant to be in each of the states that a card would go through. So, a card would start off new, it would be groomed, which would be clarifying that what it's supposed to do, its value, what the criteria was that, it needed to be accepted or to be tested. And then a team would put an estimate on it, and then it'd be developed, go through testing with some level of acceptance, and then it would be deployed. And I'll show you in our case of Aspire, we did a very, very similar one. We've got to do, in progress, code review, awaiting deployment, ready to test, testing in progress, roadblocked, UAT, and done. So every team I've worked with has a different value stream and they define it slightly differently. This one started off a lot simpler than this, but as the team size grew and people moved more into specialties, it expanded a little bit to the point where this is what we've got. And we're really happy with it. We're 17 sprints in, I think. Yep. And we're flying. It's what we need. Looks like we got a chat question. If I can bring it up. Can somebody read it to me? I'm not sure I can bring it up while I'm full screen. John, can you see it?
I think we're good now. The question's been answered.
Okay, cool.
Yeah,
Awesome.
we're good.
All right, so yeah, so that's defining a value stream, and then of course seeing the work go through there, and then the next step is to make it flow, right? One of the biggest things that I see a lot of teams do is they either get really heavyweight on their process, and then they argue about how it works, or they build a very simple process like this one, which only has 4 columns, and they just start flowing, and they inspect and adapt and grow it and get more productive as they go. So again, our at Aspire, this project's been going about 9 months now, 10 months, and we certainly didn't start off with this level of sophistication, but we kind of grew into it, and it works. And it works because each person knows exactly what to do at each step of the way here. And the big thing about Lean is it's a pull-based system. You don't push work. You don't have some project manager and a technical lead defining all these requirements and saying, okay, Clint, you will have these 5 stories done by next Friday. it's capacity driven and it's a pull-based system. And I don't think we have time tonight to watch this video, but if you search for I Love Lucy Chocolate Factory, this video is an absolute pristine, perfect example of how not to do a lean process. They basically, this lady comes in, teaches them how to wrap chocolates, and then they start speeding up the line and say, oh, you guys, you're getting really good at this. I'm going to make them go faster. And eventually it just turns into complete chaos. So a perfect example of some of the lean principles and the anti-practices of lean and how it should work. So I encourage all of you guys to check that out. It's maybe 3 or 4 minutes long. So that's it. That's it for lean. I mean, that's really, in my mind, that's what lean's all about. You know, you define that value stream, make sure everyone in the process understands how it works, and you work through it and kind of grow it and build it as you go. So now that brings me to the Agile side of the house. So Agile at its root, and a lot of people have a lot of opinions of what Agile is, but here's my perspective on it. It is a movement driven by a manifesto. Some folks got together, I don't know, maybe 30, 35 years ago at a big, I think it was a ski resort somewhere, and they sat down and said, you know, there's really not that many ways to build software. And they kind of put together a manifesto about how they believed it should be done. And I'm not going to go through that here tonight because it's kind of boring. But I'll give you kind of my Cliff Notes version of what I think Agile is all about. So it's about people making software. And I will tell you, the best, most productive, most enjoyable projects I've ever worked on were done by people who actually enjoyed it. And that's not the case in every project I've been on. I've been on projects where you'd go into stand-ups and it was like going to a funeral. Everybody would walk in, they would hug the wall, they'd all stare at their feet. And you can imagine how well that project went. I mean, it was just not a good experience. So recognizing that people are what makes software processes work and how software gets built goes a long way towards enjoying your work and having a highly motivated and engaged and just accountable team. So, you know, recognize that if you're not having fun, if your team doesn't get along, you're probably not operating as well as you can. You have to have good collaboration with your customers. This is an example of us going through what's Scaled Agile calls a PI planning exercise, which is nothing more than a 2-day powwow with all your stakeholders and customers, mixed with all your developers, coming up with the plan, seeing the vision, coming up with how they're going to do it, breaking it down, giving the stakeholders their best guess of what a project plan might look like and what the estimates might look like. And if you've never been in one, it is a heck of a lot of fun. You know, the smallest size, they can be done with one team and one small group of customers, maybe, you know, a day or so. In this particular case, it was about 100 people, and 3 or 4 different divisions of the company all got together and just cranked out this incredibly complex process for doing credit card merchant onboarding. So it was a lot of fun. Delivering value. Hey, this is a repeat from the lean principles. This is cumulative flow diagrams from several teams I've worked with in the past. I'll tell you, having worked with these different teams, you can see which ones are delivering value. And the ironic thing is those teams were happier, healthier, more productive than the teams that weren't delivering value. The teams that weren't delivering value were absolutely miserable. And there's lots of reasons why. And, you know, we work with teams all the time, work with companies to help them get through and break through these hurdles and get to a point where their teams are highly productive and delivering great value to their customers on a regular basis, right? Just a continuous stream. And I think I have the one up for Aspire here. Let's see what I do with it. Yep, here we go. So it's funny, the characteristics of teams that I've seen that have been productive and highly successful is this graph almost always looks the same for effective teams. Because this kind of starts off slow as the team starts to form, and they literally get faster and faster and faster the longer they work together. And I'll tell you that we do a 360-degree review on all of our projects and all of our teams, and we just did one about 4 sprints ago. And by and large, everybody on the team said this is the best project they've ever worked on. Just because, I mean, success breeds more success. It's just amazing to be part of it and to see it happen. And again, looking at these different projects, you can see which teams were successful and which ones were productive and which ones were not. And each team tells a story, especially the ones that are a little jacked up. But you know, come up to me sometime when we get back to in person, and I can tell you the stories behind some of these. They all have an interesting story. And then the last portion of agility, which really, in my mind, this is what Agile is about. It's in the name, the ability to respond and adapt to change quickly. I can't tell you how many teams I've worked with that they go through this value stream definition process. They define their definition of ready. They define their definition of done, and they build it.
So,
Sorry, go ahead. Question?
is this a meeting?
Yep.
Yeah, it's a meetup.
Oh, I wanted to let you know that I'm going to deploy Zoom at 7, but
Okay.
you have to get on at 8. There's a Zoom for our camping trip with Laurie and Colleen and Carol. And I said, I'm going to have my family Zoom, but of all the days and times, I was like, I can't do this one. And it was only when everybody else
Got
did.
it.
All right. Sorry about that. Good times. All right. Anyway, my point, Agile is about agility. It's about being able to pivot, being able to change direction. And I have so many teams that they're so invested in the way they've built their process and they built their team that they ultimately are brittle because they can't change. And and this manifests itself in different ways. The process may need to change as team members come and go, as specializations change, as the nature of the work shifts from being, C# programming to more HTML and more SQL-based programming, or more, you go through different phases of a project. The nature of agility has changed, and for people to claim they're agile but not be willing to change is just absolutely mind-boggling to me. So, and even little things like, well, the customer said they wanted this, and now they changed their mind. Yes. They didn't know what they wanted until we built it, and they saw it and they realized it wasn't quite what they had in mind. All right, yep, we may have to do a little bit of rework, but in the spirit of collaboration with our customer, in the spirit of being able to react and adapt and ultimately build the best value for our customer, change is what has to happen. And it's funny. I mean, this is my last slide about Agile, but it boggles my mind to think that people who claim they're agile don't realize that agile ultimately is about being able to respond and pivot and make a difference. So that's my soapbox kind of crescendoed here. So a couple little things, takeaways. So you want to grow a repeatable flowing process. That's the spirit of Lean. And again, Agile can build on top of Lean. They are not two separate things that can't live together. They're absolutely complementary. You want to take small bites, lots of chewing. I have a whole other talk about how to make flow happen naturally and be more effective. And it comes down to doing things in little chunks, because little chunks are more predictable and more consistent and allow you to change what chunk you work on tomorrow, as opposed to something that you work on for 5 days or 10 days, and then you come up for air and realize you were working on the wrong thing. So I love the saying, small bites, lots of chewing. Being able to pivot mercilessly when you have conditions change. Again, at the spirit of Agile. And looking at that, being able to visualize your flow of your work and recognize when you're seeing bottlenecks or stalling. We had in this project here, I'm working on Aspire, we had, you can see there's quite a bit of whip going, but this is a big team. We've got 20 people on this team. It's getting borderline too big for one board. We're talking about splitting it up in 2 teams of 10. But there was one day where between awaiting QA ready to test and testing in progress, there were over 30 stories or 30 cards sitting in here. And we went to our testers. There were 2 of them. We said, are you okay? Are you sure? Are you okay? Do you need some help? We can get more people in here and help you out. And they're like, oh, we're okay. And sometimes there's a little bit of Stockholm syndrome in there. So we watch it really close. We don't want people overwhelmed. We don't want people bottlenecking, because it tends to happen is if this backs up and developers just keep piling more code, then the problem exacerbates itself and just gets worse and worse. And then understand, again, kind of one of the key points of this talk is really what's the difference between the principles and the methodology. So Kanban implements Lean. Kanban is one of the methodologies. It's not the only way to do Lean. It just happens to be a very, very popular way to do Lean. And Scrum is a very popular way to do Lean and Agile. It's not the only way to do Lean and Agile. It is an implementation of it. There are tons and tons of others. And even within these 2, there are tons and tons of variations, because you start off with by the book Kanban, you start off with by the book Scrum, but as you adapt and adjust it to fit the size of your team and the volume of your work, inevitably it's going to change because you learn and you grow it, and that's okay. I have lots of arguments with folks that come in and say, oh, you're not doing Agile, you're not doing this. Like, Not sure I agree with you about the definition. Some things to watch out for too. I call them the saboteurs, things that prevent you from doing these things, being lean and being agile. First is influential team members who aren't bought in to the ideas and the concepts and the principles. Why do we need to estimate our work? Just give me a bunch of work and I'll tell you when it's done, right? I've heard that a number of times from members of teams. Like, I just don't need this stuff. I know what the work is to be done. I don't need to estimate it. I don't need to tell you when I'm going to be done with it. It's unhealthy, especially in a collaborative environment. Old school PMs who want to manage by Gantt charts. They want to have due dates. You know, at the end of the day, we are building a pull-based delivery system. We can set due dates, but we call them milestones, and they adjust and flex as we get the work done and learn how much more work we have to do and how much less work we have to do. If you do have hard due dates, and sometimes you do, sometimes you have hard caps on the budget you have for the project. And the best thing you could do is aggressively prioritize the work you do so that when you get to that end of that due date or that budget runs out, you worked on the most valuable, most important, high need things that your customers can do. And you know, that's just the reality of it. We know that the classic iron triangle is a myth, and we use what we know about Lean and Agile to try to get us there. Seagull leaders are another thing to watch out for. Those are the ones that come, they fly in, they poop on everything, and they leave. I fight that daily right now in Aspire. Some of the members of my team also report to other leaders within the company that we're working with. And I constantly hear, well, oh, I got pulled onto something else. I got pulled onto this. I got pulled onto that. That is because somebody came in and said, oh, I know you're working on that project, but this is important. I need you to go do this real quick. It'll be quick, right? Those happen constantly, and that's a constant battle that Agile coaches and team members fight. Especially if they're in matrixed organizations, right? Where you're fractionalized. You know, Clint, you're 30% on this project and 15% on that. And the rest of your time, I need you to work with the customer to define the next generation of products. Like, all right, so where does my allegiance and where does my loyalty lie? You know, it's the enemy of focus, and it affects value delivery in a big way. And then the last one I see that happens a lot is unengaged customers and stakeholders. They think all they got to do is come in, give you a vision of what they want, and wave their hands, and the developers will just make it happen. And the reality is we need that feedback. We need it quickly so that we can build the right product the first time. The danger is we go in a corner and we build something because, you know, we know what they need. And you come back 3 months later, 6 months later, and you've got a product that doesn't meet their needs or fractionally meets their needs, and you got to do parts of it over again. Or it's unsuccessful in the market or with your customer base, and ultimately that's, you know, not value not delivered, and in my mind, it's a wasted effort, right? Nobody wants to work on projects like that. So anyway, big soapbox, but these are kind of some of the lessons I've learned and the things that are top of mind for me when I'm working with teams. I've got a couple book recommendations, and I will post these slides and put a link in the meetup. So there's a few books that I've really, really enjoyed over the years that kind of help frame my thinking. And with that, I will thank you. A couple minutes for questions if anybody has any.
Yeah, there's one in the chat for you.
All right, let's see if I can get to it. All right, how do you come up with estimates? I always struggle with estimating items. Oh, I have a whole talk on that. Maybe that's my talk for November, John. So we estimate as a team, but I'll tell you what, my team's estimates are horrible. They are consistently, let me find my velocity chart, and it's true on every team I work with. Ultimately, you need data in order to come up with a number. What we found over time is we've looked at our progress. So I don't pre-plan this stuff, right? This isn't a PMBOK style project plan. What I do is I go week over week and I track what my team has been able to do. So this particular week, this team got 14 stories done and closed 28 bugs. So we had our bug count was creeping up, so we spent more time on bugs. But what I learned is if I go look over the period of this whole project, I can figure out on average, and check that out. Remember the graph? We had 0 velocity weeks when we first started, when we were building out the architecture, kind of starting to form our team. But what I learned is over time, we were able to produce.
You're not sharing your screen anymore.
Oh, shoot. You're right. I'm sorry. Hold on. Let me share it again. Where's my Zoom? I can't share. Oh, it's minimized. I'm sorry. Hold on. Yeah. All right. Let me back up. So what we do is week over week, we track our progress. And I've been doing that with some simple data. I look at every week. We'll kind of go to this past week. So we had this week in 9/23, we had 14 stories done and 28 bugs. So we had a fairly high bug count this week that we were starting to creep up on. So we had to pay that down a little bit to keep our bug count low. But what I've done is over the period of, last 20 something weeks or so, we've gotten a measure of how many stories, including how many bugs we take care of while we're working on stories. And you notice the first couple of weeks of this project were zeros. So we ramped up just like any team does. Anyway, what I've found is over time, we averaged 2.2 stories per week per developer, not even points, right? These are just raw cards. Remember, we try to keep our cards small. All of our cards tend to be 1 to 3 point stories. And because we kept them small, the averages play out. So it's about 2.2 stories per card, cards per developer per week. So what that translates to is if I have a team size of 3, I can get 6 stories done a week or 13 done a sprint. If I have a team size of 6, of course you can do the math, right? But this was only after getting enough sample points. And by and large, I mean, we're pretty darn accurate. I mean, we lost some time. We estimated something, and it threw our backlog count way up high. But you can see we've been burning back towards our predictable line. This is because we missed the whole area of the application that we just didn't see on the screens in the original app. So we're writing a conversion and a modernization of an existing app. But anyway, how do we do estimating? We go beginning of sprint, we go to a backlog and we just walk through the stories and we read through them. We have, did I close it? We have a designer who does all the designs, and we sit and walk through them together and we come up with a shared estimate. We walk through the screen, we talk through the story, we make any notes that we have based on the discussion. And so let's say we're working on, this particular dialog box like this. We'll say, okay, we're gonna go pull a list of fields we need to display. They can change the drag and drop the order. We'll capture all that in the card, and then we vote just like anybody else does. We'll say, all right, everybody give me an estimate, 1, 2, 3, go. And we'll use the point system that we've come up with. And then I'll plug that in. And let me find something that's active right now. Let's see, opportunities. Yeah, so you can see we've got the point numbers on the cards here. Bugs, unless they're really big, we don't point them. They're usually tiny, so we just do them. So we use a typical Fibonacci sequence. But I'll tell you, they're not accurate. My teams get stuff done way faster than they always sandbag. This 2 is usually about a 1, really. But in the spirit of letting them own their own accountability, I run with it. So we estimate it. We look at the team size. We know what our number of cards per sprint is, and we kind of pop them in there and make a plan out of it. Hope that helps. Forecasting, Jim. Yes, that's where we do the long range planning. Let me share again real quick on that. So we did have the luxury of this app, but we're building this new application as a rewrite of an existing application. So we did have the luxury of having a backlog of product to basically build stories for. So here's all the different epics, and we went and we created all the cards for every one of these bad boys. And of course, we discovered new ones as we went along because we missed things. But yeah, estimating has been a pain in the butt. We do the best we can. We needed data in order to do a forecast. So until we had a reliable team up and running with a consistent velocity and reliable count of cards, it was anybody's guess. And we were off. I mean, we originally started this in February. We were supposed to be done in July. And we're targeting October 21st to finish. So we were way off, but we have been doing what I said about prioritization. We basically stacked ranked all these things and put the highest value stuff at the top. And I basically took it feature by feature out of the different epics, and we've just been cranked along. I mean, you see this is milestone. We're in our 4th phase, our 4th milestone. So we've been just assigning squads to different parts of the app. and cranking through it. So we're coming up on October 21st, and we've got about 8 or 9 features left to go. Been a good time.
I have a question.
Sure.
So if you have a developer with a question and another developer with an answer, how do you find that connection and manage it?
A developer, you mean like during the execution?
So,
Like if they're
so
working
if quite often it's like I'm given a task and it's like, oh, that's a new technology, I've never ran into it. Has anyone in the group? And we work with a large group, so it's how to find, I know some guys that I rely on, but it's just ad hoc. It's not like I'm going through a system or something. Like
Yeah.
I know guys who are smart and I just go to them.
Yeah.
Do you manage that at all, or do you?
Yes. So I use what as I'm the agile coach as well as the project manager, because they're kind of one and the same in a project like this. I use social engineering to the maximum amount I can. So a lot of times, since I also manage the backlog, somebody will come in, hey, anybody worked on, do you know who's worked on the grid, the data grid? And I'll say, talk to John. John worked on the data grid. And we encourage kind of dynamic pairing, right? Everybody will pull a card, but if they need to stop and help somebody else pair on something for a couple hours, we highly, highly encourage that. And so I'm constantly matchmaking who's working on something with who has the knowledge. I try my best to assign features to people who've done similar features in the past, right? So you don't completely get stuck on a feature you're cold on, but it does happen. And so we just actively encourage short-term pairing to help people get over the hump, because it's usually that first few hours where they have no idea how to get started on it.
Right.
And after that, they can pick it up. So there's no hard deadline on, hey, John, make sure your card's done by the end of the day. And we don't do any of that. It's a pull-based system, right? So if he has to stop and pause his card to go help Chris out on a card, that's what they do for 3 hours or half a day. We've had cards that took 5 people to figure it out, right? They swarm on it together for a few hours or sometimes a few days. If we know there's a big unknown, we'll create a research spike that's a separate card that just to go learn that, go do a tutorial on the ng grid from Angular, right? And build a basic grid to do what our designer's design needs to do. Doesn't need to talk to the database or anything like that, just build a basic grid. And that goes a long way towards solving unknowns ahead of time. And then that person can either work on the real card when it comes up, or they can give the sample code to whoever pulls it. So yeah, constantly social engineering. And it goes even beyond that. I mean, I intentionally pair, and I put them in squads. So I call it pairs, but they're really squads. They can work on stuff together if they need to, but for the most part, I assign 1 or 2 or 3 people to a particular feature just to make the feature go fast. But I intentionally pair more extroverted people with more introverted people, because the introverts will never raise their hand and ask a question till they're stuck. And an extrovert will check in with them. Hey, Tyler, how's that feature going? Did you make progress? Like, why don't I help you, right? So I pair senior people with junior people, if it makes sense. I pair extroverts with introverts. I pair people who've worked on things in an area with some who haven't. So all those tricks. So, hope that helps.
Well, yeah.
All right, cool. I know we're running behind. I'm way over, but I will stop there. Thank you guys so much.
Hey, thanks, Clint. I like hearing about real world stuff. So I really appreciate you
Bet.
sharing those details. All right, Chris, I see you're able to connect with your Android phone.
Yes, can you hear me all right?
I can hear you great. So yeah, if you want to go ahead and say a few things, then we'll turn things over to the Cameron for the night.
Fantastic, very good. I appreciate it. First, I just want to say, John and Scott, thanks for giving us the opportunity at Beacon Hill to be able to sponsor tonight's conversation. Certainly missed out on the opportunity to see all of you folks. I know a lot of you there, but it'd be great to see you. But it is what it is, and I hope you're all doing well and your families are staying healthy during this strange time. Also, one other quick caveat, I have 2 dogs, so if you suddenly hear some barking in the background, no worries, they're just acting as guard dogs. So anyway, Beacon Hill Staffing, I know a lot of you know who we are. Some names to me are new, so I just want to let you know that we are, again, a staffing firm located in St. Louis, actually in Brentwood, and our headquarters is in Boston, Massachusetts. We've been in business for 16, going on 17 years, and we've been in the St. Louis market for 6 going on 7 years now as well. Myself personally, I've been in this business for more years than I want to admit to, but you can check out my LinkedIn page and understand how many years I've been doing this business, and I certainly still enjoy it today. I do believe that the area as a recruiter, in terms of what I need to do to be successful in the IT market here in St. Louis, will and always will be recruiting for, networking with, and understanding what developers go through on a daily basis. I've been in this business, as I said, more than I care to count, but I've always tried to stay involved with recruiting application developers, software developers, web developers as well. Because to me personally, I think that's just the most fun. Nothing against project managers and nothing against chief information officers, etc. But when you talk to people about development, you get a real, I think, fire in the belly. I think you get a real passion for what they do coming back to me as a recruiter. And to me, that energy just helps me feed my drive and my desire. So I really want to thank all of you for that earnest desire, as evidenced by your participation here in tonight's event. Definitely also want to let you know that from just a pure business perspective, we provide individuals on a contract to hire, and full-time basis. We do have a tough market. I can't ignore the obvious. As I'm sure some of you do know, the market's gotten tighter. There have been layoffs. It certainly has changed thanks to the pandemic, which we all certainly know about. However, we do have a number of good clients that are still providing opportunities, good clients that still need crackerjack sharp developers. So we certainly want to help those individuals that are feeling maybe even in a difficult market to look at new things. I'm certainly open to talking to people, whether they want to make a move now, whether they want to make a move 6 months or 3 weeks, etc. I'm about relationships. I definitely like to have relationships with people, and hopefully, as I mentioned, I know a lot of the names on this list. I look to get to have those relationships continue, and I look to have new relationships form from this event and from further connections down the line. Again, we do provide, as I said, contract to hire, and full time. I will put my email address out to the Meetup because we are doing a drawing virtually. So we're going to have a $50 gift card from Micro Center, and maybe with a little bit of John's help, because I'm not the best Meetup end user, I can make sure that we get my email address put out there. So whomever wants to participate in the drawing, just email me. I'll give it to you now. It's Coleson, Coleson, at Beacon Hill Staffing, all one word, beaconhillstaffing.com. Feel free to email me and connect with me, and like to have conversations with, as I said, anybody who wants to find out about the market or just make a connection with the recruiter for the future as well. I know we're pressed for time. If anybody has any quick questions, etc., I'll try my best to be brief but informative.
Hey, Chris, I just went ahead and put your email into the chat.
Oh, fantastic. Okay, great. No problem. Yeah, send me an email. If anybody has an email, I know we're pressed for time, like I said, and I'm sure John needs to get on to Cameron's presentation. So send me an email. I look forward to having a conversation with anybody and everybody. We'll just figure out what we need to do. Thanks, everybody. Appreciate it.
All right. Thanks, Chris. We appreciate it.
You bet.
All right, Cameron. I know the night's a little longer than you expected. But yeah, feel free to go ahead and share your screen and jump into your talk.
Yeah, absolutely. So while I'm doing that, we'll go ahead and get things squared away here. So part of being agile, right? Roll with the punches, technological glitches and such, right? So if everything's working correctly, you should be able to see the first slide of the slide deck. Is that true?
Yeah, it looks good.
Wonderful. John, if you don't mind being my moderator for this evening, at certain parts in the presentation, I'm going to take a pause and go through questions. So if you'll help me moderate the questions in the chat through the presentation, that'd be wonderful.
Yeah, that's what I plan on doing.
Wonderful. Thank you. Cool. All right. Good evening, everyone. My name's Cameron Presley, and if you've survived all the technical hiccups and everything else tonight, you're here to learn about functional programming from the ground up. Super excited to be here this evening, even through all the technical mishaps. First things first, there are no need to take notes this evening. All the resources you're going to see tonight, book references, code samples, slide deck, all of it is already live. For those of you who like QR codes, you can scan the one on screen, or you can go to my website, blog.softwarementor.com, go to presentations. You'll find it right there. I'll also be posting all the links in the Zoom chat after the presentation. So if you miss it here, no worries, we'll get you caught up. So a little bit about me. I am a lead software engineer for a company called SentryOne, where we write software to help the Microsoft data professional. If you've ever found yourself asking questions like, why is SQL Server running so slow? Why is my query running so slow? Oh goodness, why did my ORM of choice generate a query like that? What's going on? We probably have something to help you out. For those of you who have fun tuning your own SQL queries, check out Plan Explorer. It's one of our free products that will help you troubleshoot basic query mistakes. If you're interested in knowing more about some of our products or some of the stuff I work on, let me know. Love chatting about data and having to learn the deep, dark bowels of SQL Server at times. But enough about me. Let's talk about the concepts for this evening. So what we're going to be talking about is these concepts of functional programming from the ground up by looking at a code example, a kata known as Mars rover. So I'm going to assume zero knowledge and go from there. So we'll go over the kata, some of the ground rules, and we'll actually look like how do we solve this problem using functional concepts. Now, all the languages that I'll show you tonight are in C#, but you can add these concepts to pretty much any language you work with. It's just that the syntax may be slightly different. But after going through roughly the problem we're trying to solve, we're going to look at these three main principles when you're working with functional programming. So the first concept is going to be this idea of immutability, these immutable data models. What do we mean by that? What's so important? Why should we be following that? And how that, well, if you don't really have immutability, you may run into problems later down the road. After we've gotten a pretty good concept of immutability, we'll talk about functions, this idea of what's a pure function? What do we mean by that concept? And why is that so important? And how maybe it helps us write less error-prone code. We just saw the previous presentation, right, about how velocity and writing cleaner code and solving bugs, right? Pure functions can help us a little bit with that. Once we've kind of set up a ground level of these immutable data models, and now we've got functions to work on them, we'll start talking about how do we build bigger programs by composition, right? How do we compose these functions together to build bigger and better software? So throughout the course of the night, you'll see us build up upon all of these concepts. So super excited to get into it. So with that, let's go explore Mars. Let's go check out this kata. So here is the scenario, the problem that we're trying to solve. We are part of a team that is going to be exploring the surface of Mars by sending these remotely controlled vehicles to the surface of the planet, right? And so our job is we're going to develop an API that translates these commands we're going to send from Earth in such a way that it can be understood by the rover. Now, thank goodness we have electrical engineers and mechanical engineers that are going to help us build the rover itself. So we get to focus more on the software and more of the API that's going to use. API in this case could be a web API, but in our particular instance for this evening, we'll be keeping it as a command line interface to kind of reduce some of the complexity here a little bit. So let's take a look at some of the requirements of this exercise. So we know that this rover will always start at a coordinate plane of 0, 0, and it's always going to be facing this direction of north, right? And throughout the course of this emulator, valid directions that the rover could face are north, south, east, and west. And some of these commands that a rover could understand are like the following. So a rover could move forward, it can move backward, it could turn left, it could turn right, and then it can quit by just stop receiving commands. So a pretty simplistic API, but you can maybe start thinking of some edges or maybe some wrinkles in the business rules here a little bit. So with that being said, let's start breaking down this problem. So in typical fashion, when we break down a problem, I like to think about the nouns, right? What are the things that we're interacting with? And so when we look at this problem description, there's a couple of nouns that kind of jump off the page to me. So it sounds like we have this concept of a rover, right? We don't quite know everything about it, but we know it's a thing. We also know that there's this concept of a direction, and we also know that there's a concept of a command. Okay, well, as we start thinking about that, we can start really thinking about how do we model this type of stuff? Like how do we model these types? So for those of you who are maybe new to functional, this idea of modeling types and designing a good type system is something that you're going to spend a lot of time thinking about, right? Because you want to write software that prevents the developer from making mistakes, right? So since command can only be one of so many things, and then direction could be of one of so many things, we can actually use this enum data type in C# to model such a thing. Now, in other languages, there's other concepts we could have done, but this is actually a pretty good place to start, right? By defining command and direction like the following, we've prevented developers from accidentally specifying command that doesn't exist or a direction that really doesn't exist in our application. Pretty cool, and not too much code, and it's somewhat readable. Kind of nice. So we've talked about command, we've talked about direction. Let's look at rover a little bit. So we talked earlier that rover always starts at 0, 0 facing north. So maybe our first thought is we define a rover class like the following. It's got a couple of properties, x and y as integers, and it's got this direction property of direction. So we've defined a data model this way, but we've got some fun little hiccups in this. So the first wrinkle we're going to run into is how do we enforce that whoever uses the rover class actually sets all these properties? Right? Like how can we do that, right? Because it doesn't make sense for you to not give some default values here or some initial values, right? Otherwise you're gonna have a bad time. So one thing we could do is we could introduce a constructor, right? So by adding this constructor, we are informing the developers and the consumers of our code saying, hey, if you're going to create a rover or instantiate this thing, you have to give me an X value, a Y value, and a direction it's facing. So right off the bat, by being a little bit mindful about how we define our types and how we interact with it, we can prevent developers from making mistakes and for accidentally using default values when that may be not their intent. But let's go a little further into this. So like we just talked about, by making this constructor, we're forcing developers to specify values, and that's a good thing, right? Well, maybe. Let's take a look at some code. Let's say I've got this function as such, right? Log rover. And what log rover does is you give it a rover and it's going to print a string to the screen, right? Rover's at this values facing this direction. And then we're incrementing X by 1. And that's kind of weird, right? Because I don't know about you, but if a method's called log rover, I wouldn't expect it to increment an X value, would you? Probably not. So especially if it's that and it's a void method. So based on those two things combined, I wouldn't expect rover to have changed or modified. I would expect that if I call rover, let's say 5 times in a row, that rover wouldn't have mutated. It wouldn't have changed. But there's nothing preventing me from writing code like this. And that's kind of no bueno, because it makes it harder to keep track of why did certain values change throughout my code base. So what are some things that we could do to kind of limit the amount of, limit this risk a bit? Well, one thing we could do is we could modify the definition of rover and get rid of the setters. By doing so, we've essentially made these fields read-only. So this means that anytime we create a rover, you have to specify an X value, Y value, and direction, and there's really no way to update it. And you're probably thinking, Cameron, that seems a little bit silly, but you'll see in a few minutes why actually it's not a bad idea. Now, this is the current way that you can try to get some immutability in your C# code today. However, with C# 9 and .NET 5, this was kind of shown at Build earlier this year, but it's coming out, oh goodness, I think in a couple weeks from now, maybe sometime in October, I think November at the latest. In .NET 5 and C# 9, you actually get this really nifty record syntax that essentially does everything on the left side of the code in fewer lines of code, and it gives you a lot better APIs to work with, which is pretty cool. And some of the code I'll show you tonight will use some of that newer syntax just to kind of get you exposed to it, which pretty neat. So given the change we just made to rover, let's look back at the log rover method. Right off the bat, you're seeing a couple of changes. In particular, it's these 2 lines, right? We've now had to update the log rover method to, instead of being a void method, it's now a function that returns back a rover. And the reason we have to, is because if we wanted to change the value of rover's X value, we've got to create a brand new rover, right? And so with this change in mind, it makes the code a little bit more obvious in what its intent is, right? When I look at log rover and I see it returns back a rover, I, as a developer, look at that and go, huh, that's a bit weird. Why is it doing that? And then when I look at that method, I go, okay, for whatever reason, it's incrementing the X value. Maybe this is a poor code design, but maybe there's something else I'm missing here. But what I've found with like putting this immutability in place, it makes me really think about how do I want my code to change? It makes me think about how do I want these different components to play together. So with kind of that splash, let's actually kind of put some terms to what we mean by immutability. And you're going to hear this term a lot tonight, and you're going to hear this term a lot when talking about functional programming. So when we say that something's immutable, we're saying it's an object whose state cannot be modified after it's created. And the reason why we may care about this is that the bigger an application gets, the harder it is to keep track of how did the state change throughout the application. So if we can limit where this state can be updated, it makes troubleshooting and debugging a lot easier. And you'll see that without immutability, it actually makes it a lot harder for other functional concepts like pure functions and composition to actually work. So I know I've covered a little bit of ground here, so I'm going to take a pause for a minute and ask John. John, do we have any questions in the chat so far?
None yet.
Okay. So really quick, do people want to do like a quick like show of hands in Zoom if everybody's like kind of following along, making sense so far? So it's a little hard to get feedback on a Zoom presentation. I just want to make sure that everyone's kind of like, yeah, okay, it's a little bit fuzzy, but I understand at least where he's coming from. Wonderful. John's get it. So John's gonna be my number 2 for the night, man. If nothing else, he's gonna ride with me here on this. We'll make it work. So with immutability, let's talk about functions. Let's talk about rules. So if you recall, one of the commands that we could issue to the rover was this move forward. So let's look at those business rules for a minute. So like everything else, there's some business rules, right, with moving forward. It's not as easy as you think. It actually depends on what direction the rover's facing. Because if it's facing in certain directions, the Y value will change as appropriate. And if it's facing other directions, it may be the X value. So it's not just as blatantly obvious as like, oh, just always increment one like X value or blatantly increment Y. There's a little bit of a wrinkle. So with these business rules of how moving forward works, and with the design limitation of of immutable objects, what does that mean for us? So essentially, based on the state of the rover, we need to create a new rover with the updated values. So let's look at some of that code. And before I say look at this code, and you can tell me I'm a developer, right? I'm already like, oh, let's look at some C#. Let's take back and think about this abstractly, right? So what we're saying is that based on the state of the rover, so let's pretend that this left circle represents all rovers, and this other circle represents all rovers as well. So if we have a rover facing north and we call this move forward function on it, it's going to map us to a rover such that the Y value has incremented by 1, right? Same thing for facing south. If facing south in this first circle represents all possible rovers facing south, when we call that mapping this move forward function, then it should give us back a new rover where the Y value has been decremented by 1. And so on and so forth for east and west appropriately, right? So when we're talking about functions and these rules and things like that, there's a couple of questions we need to ask ourselves. The first one being, are there any directions in the first group that aren't mapped at all? So long story short, is there anything in that first circle that has an arrow that doesn't go anywhere? The answer to that question is no, right? Each of those directions has an arrow going somewhere. And if that doesn't, and you'll see some examples of why that matters in a minute, but the second question we have to ask ourselves is, are there any directions in that first group such that when we try to map it over, it could go into one of 2 different groups? So for example, does facing west have 2 arrows coming out of it? No. When we have mappings like this, this is known as a pure function, and it makes our lives so much easier when it comes to data modeling. But I've always wanted to do this. Conjunction, junction, what's your function? Put a little bit of Schoolhouse Rockin' in this. So what do we mean by a function, right? You've seen it in an abstract, but let's get a little bit more technical details. So the more of a mathematical definition of a function is that it's a mapping between two sets such that every element in the first set maps to a single element in the second set. And you're like, but Cameron, I don't deal with sets. I'm not a mathematician. That doesn't work. Well, it kind of does. Replace the word set with types. Now, maybe this is making sense, right? A function's a mapping between two types such that every element in that first type maps to a single element in the second type. So let's look at some examples. Let's talk about days in a month, right? We all love date time math. That's never bitten anyone in the rear before. Let's look at some dates. So let's say we have this first group called months, and it represents all the months in a year, right? So January, February, March, April. I know they're jumbled, but there's a reason for it. And then let's say we have another type or a set called number of days. So we know as developers that every month of the year is either going to have 28, 29, 30, or 31 days. There's never a month that has 32 days. There's never a month that has 27 days. A grade and a little bit above this presentation. So for example, if we had a function that says how many days are in a month, when we call it with March, we know it's always going to give us back 31. Same thing for January. January has 31 days in a month. April has 30. But February, oh goodness. February is interesting because it points to one of two values. That's a problem. I don't know about you, but what should we do? Like if you had to write a function that given the month of February, it had to tell you how many days in there, what would you do? Would you always return 28? No, because that means you're going to be wrong at least a fourth of the time. Do you always return back 29? No, because that means you're wrong probably about a quarter of the time, right? Do you just do math.random and flip a coin? Odds ain't great. So when this happens, we know that this function's not complete. We don't actually have enough information. So for us to really write a function that tells us the days in a month, we need two pieces of info. We need to know the name of the month. We also need to know the year. So this is an example of not a function because we have an element on the left that could map to one of two different elements on the right. Making sense so far? Kind of. Thumbs up in the chat, or you can just shout at me and be like, Cameron, you're talking nonsense. No one does their own date type. Wonderful. Once again, man, John's giving me a thumbs up, so we'll keep the ball rolling. Okay. So let's look something a little bit, still in date time math because we're terrible developers. We're going to keep in that. So let's talk about mapping integers to months. So I've got a set of integers, right? And so, but when we talk about the integer type, it can have all sorts of values, right? So in this case, I've got the numbers 1 through 13, but we actually know integer maps from negative a large number to a positive very large number. And then we've got the set of all possible month names. And so far, so good, right? 1 goes to January, 2 goes to February, ... 12 goes to December. Oh, 13. What do we do with 13? That's a problem, right? Because what should we do? Right? We shouldn't return back January. That sounds like a bad idea. But it's because I don't know about you, but there's really no 13th month in the year. So if you were to try to do this in C# or most other languages, it's probably going to chuck back an argument exception or some other runtime exception. And so because this happens, this also isn't a function because for every value on the left, it does not have a value to the right that it maps to. 13 doesn't map to anything that's a month name, so it's not a good function. Doesn't even follow the definition. So let's look back at move forward, right? So with this mapping, we could write some C# code on this. So this example, so here's a function we wrote called move forward. It takes in a rover. We do a switch on that direction. And with yof, you can look at in the repository, it's just a shorthand to update a certain property on rover by creating a new one. So that way you're not saying me just do new rover all over the place. Once again, with the record syntax in C#9 and .NET 5, this gets a lot easier to parse, but for this presentation, that's what I got to go with. And you can always look at the code samples online. But we have a pure function, right? For a rover facing any direction, there is some behavior. Now, the reason why I had to do the default return is actually a limitation in C#. It wouldn't let me just not have something there because I have to always return back a rover. So to follow the type signature. But yeah, so the reason why we want to do these pure functions, these functions that follow these rules, is because I like to use code that works. I like having code that's consistent. I like having code that if I tell the add function what's 2 plus 2, I love it when it gives me back 4 and not exceptions or kumquats or whatever other thing it's thinking of doing that day, right? And so why this hangs up on me is that we work in languages that have types. So what good does it do me if I call a method and it says, well, you give me 2 integers, I'll return you back a number, and then it doesn't do that all the time. It sometimes throws me exceptions. Now I have to go read stuff. I have to go read the docs. I have to go read the manuals. And you know what, as well as I do, no one ever reads the docs. No one ever reads the manuals, right? So why can't I let the type system actually work correctly? Why can't I let it do more of the heavy lifting? So I'm going to take another pause here and talk to John, see if there's any questions in the chat, anything else we need to talk about before we go to the next section, still in functions, but I just want to make sure this is kind of clicking so far.
Yeah, I think a lot of us are just absorbing.
Oh, goodness. All right, cool. Well, if I don't start getting questions, the number of dad jokes have to go up because I've got a 2-year-old, so that's how that's got to go.
There you got one.
All right, man. I knew it, man. The minute I said dad joke, someone's like, nah, not tonight. Not tonight. Okay, cool. What's the question?
How do we solve the Fed month mapping problem?
Yeah, so to solve the February month problem, right? Like what the days in the month, I'm assuming is the question being asked. It's that you actually need a function that takes in 2 parameters. It needs to know both the month and it also needs to know the year, because now you have enough information to know what to do. Great question. Oh, seems like there's another one. Or is that just a follow-up? Well, I've scared John. He's put himself on mute. It's like, nope, not going to do it.
I think that's it for now.
Excellent. Okay. So getting back on track a little bit, we've talked about when moving forward. Let's talk about when turning left, right? Because as you can imagine, when moving forward and moving backward, they're kind of similar. So look about turning. So when we tell the rover to turn left, what's actually going to do is it's going to rotate in place. So the X and Y value doesn't change, but the direction it faces is totally going to change. So if the rover's facing north, it's going to turn west. If it's facing west, it'll turn south, so on and so forth. So how would we implement this? Well, let's do the diagram again, right? So we've got this circle that represents all rovers, and then we've got another circle that represents all rovers. And then in the circle on the left, we're going to start showing, we're going to start classifying all of the possible rovers. So on the left, we're going to say, well, this one represents all rovers facing north. And when it calls this mapping function, it now gives us back all the rovers that face west. Same thing with south with the same mapping, right? So on and so forth. Nothing too terribly crazy. So, okay. This is a function, right? Because every element on the left maps to a single element on the right, and there's no element on the left that doesn't map to anything. That like just maps to nothing, right? So everything's been specified. So because of that, when we go write the function turn left, it's like, all right, cool. Once again, like, okay, faces east, west, so on and so forth. Once again, because of the type signature, I have to specify a default return type. But notice how this code's kind of clean, right? Like it's kind of testable, really, right? I put like, given a known state, run some business rules, you get a known state back, right? I'm not having to do any crazy integration tests or anything like that, which is kind of fun. So seems like there's a question in chat, so we'll take a pause here. See if John can help me out a little bit.
Yeah, one just appeared. This is the difference between partial and complete functions.
Yes, that is totally terminology. So a partial function would be the square root function in .NET is an example of a partial function. You give it a negative number, you're going to have a real bad time because it doesn't always give you an answer, right? So yeah, whereas the squaring function, take a number and square it, that is a total function because for any input, it'll give you back an answer. Great terminology drop there. So let's talk about user interaction, because, you know, for those playing along at home, you're like, Cameron, you're just cherry picking stuff, man. This is really easy because you're picking super easy business rules, blah, blah, blah. I work on much harder stuff. How do I deal with this? I deal with things that are stateful. How do I work around it? I'll show you. So here's how we're actually going to do the modeling, honestly, of this application. So we know at a very high level that the user is going to enter input somehow. Maybe it's through the, in this example, it's a command line, but it could have just been easy an API call, right? Could have been a web API call, no problem. But we still need to do the following. We got to get the input from somewhere. Once we have that input, we got to map it to figure out, like, okay, what command did the user actually want? Once we know the command that the user wanted, we need to figure out, like, okay, what logic do we need to call? Which one of those 4 functions, right? Moving forward, moving backward, turning left, turning right, what do we need to call? And once we figured out the thing we need to call, we need to actually invoke that business rules with the rover. And then once we've invoked that action with this rover, we get this new rover back, and that's how we're going to update with this new state. So we're essentially going to always be throwing out the old value and holding on to the new value, kind of like an accumulator. For those of you playing along at home and familiar with Link, you can kind of think like an aggregate-ish type system happening here. But before we go too deep into that, let's start breaking down these steps. All right, well, we got to map input, whatever input from the user, to a command. All right, well, let's go back to our diagramming again, right? So we've got a group that represents all possible strings. So we got some F's, some B's, some L's, some R's, and Q's for forward, backward, left, right, and quit. And we've got a group that represents all the possible commands. And so far, kind of straightforward, right? F's go to forward, move forward, B's go to move backward, L's go to turn left, so on and so forth, nothing crazy. Oh, but there's a problem. We just said that group on the left represents all possible strings, didn't we? Because it's getting user input, right? That means the user could literally enter in anything, like platypus. Man, if you have a really good QA, they're going to throw like garbage input into your application. So what do we do? How do we model the platypus input? And you're probably thinking, oh, Cameron, we don't, right? Like what do we do here, right? So for this to really be a good function, right, it's got to be able to handle all these inputs somehow, but sometimes you're going to get crap that you don't know how to deal with, right? And so that's kind of our problem, right? The input could have been any string, but we can't map everything. So when you find yourself in this situation, you've got really one of two things you can do. You can either restrict the input to valid values. So in this example, so if we try to do that first option, we would have to figure out a string type that could only ever be FBLRQ. And I don't know about you, but that seems really hard. That seems hard to put types in like that. So what we can do instead, so if we can't restrict the inputs, we can't restrict the domain any, let's expand the range. Let's expand the code domain and expand what the possible values are. So in this example, we're just going to introduce this brand new command called unknown. We're essentially going to say, you know what, if we don't get one of these characters, like if it's not an F, a B, L, or a Q, we don't know what to do. We're just going to say it's unknown. So that's how we're going to map this. So when we go to write this function that maps a string to command, we can actually write the following, right? So we'll do a switch statement on the string and do that hop potato operator (dot) to lower it. And if it's, you know, FBLRQ, we give you back the right commands, that command enum that we defined at the very beginning. And if it's not one of those 5 things, you get an unknown command. Don't know what to do with you. Okay, well, I'm going to take another pause here and see, because I saw some, it looks like some questions happening in the chat. So I'm just going to check in with John here and see, make sure we're still doing okay.
Nothing new yet.
Wonderful. Okay. So we've got a way to go from string to command, and now we've got to figure out a way to go from command to an action, right? How do we map one of these command enums to an action? Action being one of those methods that we wrote earlier, either move forward, move backward, so on and so forth. So once again, we're going to do our diagramming, right? I've got a circle representing all the commands, and here's the fun thing that maybe wasn't super obvious when we covered it, but was true. For move forward, move backward, turn left, turn right, those were all functions that said, if you give me a rover, I'll give you back a new rover. So the mapping of this kind of looks like the following, right? So all the commands are either move forward, move backward, turn left, turn right, quit and unknown. And then the group on the right is the actual functions, the actual business rules that we defined earlier. And so far, there's a pretty straightforward one-to-one mapping until, quit and unknown. We don't know, we didn't write rules for those yet. Like what should we do, right? So how should we update rover if the commands quit? We don't know what to do. Well, what if we do nothing, right? If you tell us to quit, we definitely shouldn't be doing anything. So doing nothing makes sense. And if we don't know what to do, maybe we just don't do anything at all. We just kind of sit there. So let's write that. So there's your do nothing command. You give it a rover, it just spits it right back at you. For those who have a little bit of a functional programming background, you'll know this as the identity function, right? Takes in whatever it was passing and returns it back. But once we have this do nothing method, all of a sudden we can complete this mapping correctly because now do nothing has the signature of rover to rover, and we can now map quit and unknown to it. And once we've kind of got this mapping in place, we can write this new function, convert command to action. You give us a command, we'll give you back a func that goes from rover to rover, and we do a switch statement. So we've got all the commands covered, and if it's not one of those commands, we do nothing. So as you're seeing, as we actually start thinking about types and thinking about like how do we write functions that essentially try not to throw exceptions and such, you kind of start writing a little bit of robust code. And once again, some of the stuff starts becoming, I won't say trivial to unit test and test, but dang it, man, it's got to be a little bit easier and it's a little bit easier to follow. So at this point, right, we've got our data types, we've got these business rules implemented, we're working through the workflow, but we got to bring this thing all together. So here's what our code would look like at this point if this was a console app, right? So we've got a rover so we're running this in active mode. You've given us some rover. So it's starting at 00 facing north. We've got an initial command of unknown. While the command's not quit, we print some stuff to the screen, and then we get the command. So we'll say, hey, converters, convert the string to command wherever you gave us from the console. And then once we've got that command, we convert it to the right action, and then we pass in the rover to the action, and then we save the result for rover for next time. So this while loop, funny enough, is what's actually doing our state management, which is kind of nifty. So I'm gonna just highlight there real quick. And I'm seeing a little bit of chatter in the chat, so let's take a moment here.
So Michael's asking, are the commands an enum and rover commands are predicates?
Okay, so the command is an enum, and the func that goes from rover to rover, that's not quite a predicate. So a predicate is something that goes from a value to a Boolean. So predicate's not quite the right word there. But otherwise, yes, your description's totally correct, Michael. Cool. Were there any other questions in the chat, John, or was that one it?
Oh, that was it.
Okay, perfect.
Okay.
So this implementation of the kata like allows users to put in inputs, right? They allow you like, okay, because of the console read line, right? Kind of nifty. But what if you knew all the commands already, right? What if someone gave you a list of commands? Well, your code would look a lot like this. So we would prompt the user, hey, what string of commands to process? You just give us the string. We'll print to you what the rover current location was. And then we've got some cool link going on. So we'll take that input string, we'll break it down into the single characters. That's what that first select's doing. And then for each of those characters, we're going to convert them in, for each of those characters that were converted to a string, we're going to convert those to commands. For each of those commands, we're going to convert it to the right action to call on rover. And then I kind of hinted on this a little bit, but then we can use the aggregate function to essentially say, okay, given rover as our initial state and these list of functions, here's what I want to do to update the rover. So this entire block in blue is what's kind of doing all the state management once again. It's actually like processing all that. And then once we get through this block, we can actually print to the screen, hey, here's what the rover stopped at, right? Because we ran out of commands to process. Now, one thing you may have noticed is that this code has a very interesting structure to it. Primarily, the things in red, like you've got a block of this red code, a block of blue, and this block of red. And it actually gives us what's easy to test and what's not. So anything in the red block is really hard to unit test because you're having to interact with the console, right? You're either doing write lines or read lines. That's really hard to unit test. So, and at integration testing, you're like tying in like streams and stuff. So, I mean, you could do it, but that seems a bit rough. But the block in blue, that bit right there, that's super testable. And what's really nice, those are all the business rules, right? Like that's all the business rules. I don't know about y'all, but like where I'm at, like where I work and most of the companies I worked at, they don't want to pay me to like deal with parsing input, right? Like no one ever says, oh, Cameron, we need to give you this large sack of money because we need you to parse a string. It's always, hey, we've got these really complex business rules that given some input, it's got to go through this Rube Goldberg machine of stuff and then spit out whatever the answer is. And so if that's the case, let's make all that testable. And you see, we kind of follow this pattern here. Right? Impure stuff that we can't control very easily, which is the console, read lines, write lines, pure business rules that are super testable, and then more of the impure stuff at the end. This type of structure has a lot of names to it. There's if you've ever heard of clean architecture, this is kind of an implementation of that pattern. Hexagonal architecture by Alistair Coburn is kind of like this as well. So let's dig in a little bit to this block in blue. Now, for those of you who've been using Link a little bit, there may be something standing out to you, and it's this idea that we're iterating through this list like 4 times, right? Because we're calling a select, and then we're calling another select, and then we're calling another select, and then we're calling an aggregate. Oh, how annoying, right? Because imagine if this is a very long string, and maybe each of those selects were kind of expensive, right? So we don't want to iterate this list all the time. Or let me phrase it a different way. What if that input, instead of coming from like a string from the console, it was coming from like an async call or something, right? Like something we don't want to process all the time. Is there a way that we could shorten this up so that we're only processing it maybe twice or only once? Yeah, let me show you. So what I found when working with Link is that if I find myself doing multiple selects in a row like this, it kind of looks a lot like this, right? So with the code we had, we're taking some string, going to a command, and going to an action. Wouldn't it be nice if we could cut out the middleman? Yeah, we can. We can use composition. And the only reason why we can compose these things together to make a new function is because we had pure functions to begin with, right? We can go from string straight to action because everything maps in between. There was like strings to command was a pure function. Command to action was a pure function. Because everything was a pure function, we can compose all of it. So when we're talking about functional composition, we're really talking about the following, right? It's an operation that can take these F and G functions and produce a new one called H. And another way to think about it is that if we've got something that goes from A to B and something that goes from B to C, then we can easily construct something that goes from A to C. And you can actually write your own composition function in C#. It's not too bad. If you ignore the parade of angle brackets because we're working with generics, you could legitimately take this code, drop it in your C#, and you've got function composition. So once we've got this way of composing functions, right, and you can kind of see it on that first example, right? You gave us a function that goes from T1 to T2, and another function that goes from T2 to T3. I can give you a function that goes from T1 to T3 just by kind of nesting A inside of B, right? But once we've got this, we can now rewrite some code. So, you know, we had that huge block in blue earlier. Well, we can write a new composition like the following. We can say, hey, we've got a function that says, given a char, I'll give you back a function that knows how to go to rover. And what it is, it's the composition of a toString function composed with string to command, composed with command to action. And once we've got this new composition, we can get rid of all of those selects into a single select. Fantastic. We can actually go better, right? So if we can get down to a select and an aggregate, we're still iterating the list twice. We can actually get down by 1 just by using aggregate. And so what we're doing here is for every character of C, we're going to convert it to an action, which we can do because we have that composition. Now that we have that in action, we now pass Rover into it. So we took that huge pipeline we had before and shrunk it down to a one-liner. And the way we were able to do that is because we were able to compose functions. The only way we were able to compose functions is because all those functions were pure, right? They always mapped to something. And the only way, really, I didn't talk about this a whole lot, but the only way that we had those pure functions to begin with is because when we passed in a value, the value couldn't change on you halfway through the function call because they're immutable. This all builds together. And to me, that's really cool. So I've seen a little bit of chatter in the chat window. So I'm going to take a pause here and see if, what that's all about. So John, can you help me out a little bit?
Yeah, Scott just made a comment. Calculus, I thought we told our instructors we'd never need this stuff.
Oh, goodness. Yeah, I know, right? Like you think you're done with math, but you'll actually find that math is all over the place. And I'm going to kind of go a little bit further here real quick. The reason why this stuff is really important now more so than ever is that if for those of you who do web development, you're seeing these concepts all over the place now. If you're using React with Redux, you just saw how that worked with that pattern with the aggregate. That's all it's doing, right? You had reducer functions that says, given this state and this command, here's your new state, right? Elm, if you're familiar with that architecture, follows that idea. At MS Build this year, they announced Maui, right? And one of its things was the model view update pattern, right? So you're seeing this stuff hitting the mainstream, and it's been here for forever now, right? Just in other languages that you may not have been exposed to. So now's the good time as any to start getting used to these concepts.
Yeah, that's a good point. There's also another comment that says this is also lazy evaluation.
Up until we did aggregate, it was. The minute you do aggregate, that's no longer lazy evaluation. But when we had all the selects chained, absolutely. But aggregate, the minute you call that, it will force everything to evaluate. So hopefully that answers the question in the chat.
Yeah, that makes sense.
Yeah.
That's it.
Okay. Well, cool. So let's wrap up a little bit here then. And I'll say you've all survived your first introduction to functional programming. Hopefully it wasn't too painful. And it's a lot, right? And if you're like me, you're just going to want to grab some code, play around with it, write some code, get yourself into trouble, and that's fine. But if you only had to take away a couple ideas, here's the ones I'd recommend, right? Immutability. Big thing it provides you is it removes the ability for random modifications to state throughout your application. And by removing that random access, it reduces the complexity of the code that you need to troubleshoot and to debug, right? Functions. There's these really cool mappings that let you go from one type to another, and it allows you to force for everything on the left, you have to have a value for the right. And once you have both these concepts in play, we can compose them. We can take these smaller functions, these smaller programs, and compose them into larger programs, right? And all of this stuff drives together. So if you're wanting to know more, right? Because if you're, I like looking through code, but I also like seeing how other people approach problems, right? Here are some resources I found super helpful. So if you're in the .NET world, like you really like C#, F#, all that, Scott Voloshin has done a Thinking Functionally like series of blog posts on F# for fun and profit. I highly recommend anything he's done because even those in the Thinking Functionally series, it's not all F#. A lot of it's not. It just gets you in the right mindset. Like, how do you think about functional programming? If you do any domain-driven design or domain modeling, get domain modeling made functional. Buy that book like yesterday. It is a fantastic read. It introduces a lot of really good concepts. And for those who want to kind of sink their teeth in a little bit more of a complicated app than Mars Rover, he kind of goes through one, which is nice. If you're more of a JavaScript, TypeScript type of developer, Professor Frisbee introduces composable functional JavaScript is a great example. There's a video series through Egghead.io that does that. Brian Lonsdorf, the gentleman who wrote it, also has the entire book on GitHub for free. Kyle Simpson has a book called Functional Light JavaScript. You might know him from the You Don't Know JS series of books. And if you're like, Cameron, that's cool, I just want to pull down code. All the code you saw tonight is already on GitHub. FP through Construction Fundamentals. You can look more into it. But with that being said, y'all, thanks so much for letting me hang out with y'all tonight. I had fun, even through all the technical hiccups, that's cool. I mean, this time it's gotta be able to react. So if you've got questions, I'll be around for a little bit. If you don't feel comfortable asking questions here in such a public forum, you can always email them to me. But I do have one small favor. And I'll post the link to this in the chat, but I'm always looking to get better. I'm always looking to improve. So if you want to go to the URL that I'm going to post in the chat in a few seconds, or go to this QR code and fill out this one question feedback form, I'd really appreciate it. But with that being said, thank you all so very much.
Thanks, Cameron. I really like how you kind of just ease your way through that, through that topic. That's great.
Well, thanks, John. I appreciate it. Man, you guys are all so kind. It just terrifies me. John's the only one speaking because he's probably talking to Scott. I was like, man, I don't know. This guy's kind of suspect. I might have regret, like can you dump the feed? I don't control the Zoom, but maybe we can talk to the other guy to like jump the, like, nah, just jump the call.
No, I'm here too. It's all good. Yeah, good session, Cameron and Clint. Appreciate both of you tonight.
Yeah.
There's a question that popped up. How do you compare C# with Haskell?
Ooh, now that is a question.
Very
So if you're, okay, so I actually do a session where I talk about how I learned functional, and I learned it through F#, right? And I made all the mistakes, blah, blah, blah. Haskell is, if you want to be like, I want to do functional programming. I want to do functional programming. I want my brain to hurt a little bit because I have to learn how to do things again. Haskell's a really good language. Actually, Haskell's one of my favorite languages to hack on, like outside of my day job. I really enjoy learning about the concepts, the way it thinks about things. It's pretty nice. Now the tooling's a little bit different, right? In my opinion, it's not quite as polished as Microsoft. However, if you're interested in learning more about Haskell, let me know. I've got a couple of books that I found to be super helpful in picking up those concepts. And really quick, I just posted in the chat the links to both the feedback form and to everything you saw tonight in the presentation. So the slide deck, the whole shebang.
So John, question for you. What's the ETA for getting this recording up on the meetup.com feedback? Is it easy? Do you know, have you done it yet?
From Zoom? No.
Yeah. Okay.
So Clint's going to provide a link, I guess, where I could possibly download the video. Then I'll put it up on YouTube.
Yep, I'll get that to you. Maybe tomorrow. I think this has to process offline for a few minutes.
Yeah, no problem.
I'll get it to you.
Oh, interesting. So someone's posting. Can someone go ahead and try doing that link again? Because I just clicked on it and it worked. So now I'm super paranoid that.
Worked for me.
Okay. So thank you, Dave H, for responding back. Because I was like, oh man, don't tell me that Google's also having an outage tonight. Because man, wouldn't that be?
What are the odds?
It turns out it's like that one server over in under John's desk that powers both Google and Azure tonight is what's gave up the ghost.
Little did John know.
It's not easy. It came up for me too.
Okay, that makes me feel slightly better, but just a hint. Oh, nothing like paranoia to make me think about other things. Don't mind me. I'm just going to go panically click in the dashboard like I know what I'm doing.
So this is Scott. It did not come up for me.
Okay, so let's try this then, because I will just, you know what?
So wait a minute. I clicked on the guy who complained about the error. Let me click on your link.
It's okay. I'll say I will just try this then. Oh, the second one has a. So the second one, as in the one
The one he posted, not the one you posted. Yeah, the one you posted is correct.
Yeah,
Okay.
the original one seems to work. The second one, I don't know why there's extra stuff in the end.
It's funny.
I'm just going to go cry in a corner and pretend I actually know what I'm doing from a technology perspective. You know, if I had written the QR generation code as a pure function, I wouldn't have had this problem. It would have given me consistent output for the same input.
Well, better luck next time, Cameron.
It's all good. So, hey man, gotta learn, man. This is feedback, right?
That's right.
I'm fully expecting someone to tell me like, hey, Cameron, can you generate a better QR code? That'd be swell.
You never know when
Yeah.
the marketing people get in the middle of it.
Actually, it'll be a product. It'll be a product owner, someone coming through. I'm just joking. So someone had, wow, people are just like slinging feedback as fast as I can. Someone's talked about error handling in Monads. Absolutely. Please. I am so willing to talk about railway oriented programming and like, how do you deal with stuff that blows up? I'm like, I am ready, but it's a bit much. You have to understand functions and all this other stuff first before all that makes sense. Otherwise it's way too much at once. Your head's going to explode. Why? Oh, that's a good question. Why doesn't Microsoft use FP in their demos? Okay, I'm going to let you in on a interesting secret. If you take a look at the way the C# language spec has evolved in the last couple of years, you'll see that it's starting to get a heck of a functional swing to it. The record stuff they're introducing, that screams immutability data, like that screams immutability, especially the syntax they chose to do like updates. It looks so much like other languages that do that concept. You're seeing Microsoft pick up more of their FP stuff. I think it's been a year now, but they introduced the span data type. Man, I look at that and I'm thinking like that's their way of doing smart pointers. There's a lot of stuff that's coming out in the language spec that's like starting to go a lot more FP in that fashion. And the person who asked why doesn't Microsoft use FP in their demos, if you take a look at most of their demos with Maui, it is very functional in nature. Very, very functional in nature. Great question. Are there any other ones?
I think that might be it.
Wonderful. On that note, I will stop sharing the screen. If I can just find the right buttons to click. That's always the fun part with these things, right? Like if I find the right, oh, there it is. Stop the share. As you can tell, I'm not a Zoom expert.